we start, if you have questions, I will answer all of them. And after that, we will start with the laboratory. And I mean that here we will have the practice for all of it. And after that, I will tell you everything you need to know about the exam. So,
Okay.
so what we have to do is just proceed, do our job, our work, finish the whole of it till the end of the semester, and after that, we will manage ourselves. We'll manage you to
We will
prepare you.
make online lectures and labs, right?
So they will be online, but the thing is the following. I ask you the following. Please read the all read the papers for the week number
Okay.
related, and after that it will be only the laboratories. If we need more time for lecture discussions, then we will open the lectures and start continue with the lectures at
Okay.
if we have to. But just for now, just take a look on the first two lectures, and after that we will. And so I'm ready to start. To be honest, and I see the other colleague Kagani is joined. He has joined as well. So I suggest we start. I don't want us to wait our time anymore. So we start with the laboratory now, and next week you will have to read the lecture number 3 for the next week as well. So
Okay.
I suggest the following: you just read all three first three lectures. Next week, if you have questions, we will proceed. We will take our time. May I ask you something else? I see that another one colleague joined the class, so I say hello to every one of you. May I ask you something else? Have you got classes after the laboratory? I didn't see your schedule, I didn't ask for it, so I'm not quite sure. I mean, if we need a longer time, we can take a little time longer, more after the class, so we can proceed that way. We have a few of the options. Anyway, all right, so may I ask you the following? Are you ready to start? And what I suggest to you is you write down everything on sheets of paper. You will need it because sometimes some of the solutions would take us more time to finish, and it would be best to write down everything because next time we will next week we will finish it. After that, by the way, we will use some of the knowledges we apply in our classes for our further laboratories and future tasks we need to proceed. So the best, and I will remind to you already now. Okay, okay, now, okay, ready. Let us start. As you can see on the screen, our first topic will be distance, angle, and vectors. Let me say just a few words as a kind of an introduction for the just for the start. Okay, so let us say the following. Uh, I mean the following: that when we study dynamics, dynamical motion or interaction, whatever the dynamics, in some older books you can read, or other newer books you can read kinetics. But that's something we will discuss in future. Dynamics comprises the motion and the forces applied in the complex motion of the machines and mechanisms. In our case, it is the electromechanical give an example like solenoid type mechanism. So electromagnetic and mechanical interaction altogether. Now, so before I continue with the rest, I just want to say the following. Dynamics comprises the kinematical motion. It is something we will start. So we will start with the basics of the distances and the vectors. Why? We need them to explain the kinematical motion of the mechanisms, and after that, using the kinematical motions, we will build another one like building blocks. So the upper block will be the dynamics of the mechanisms, where we can study the electromechanical motion of different mechanisms and devices. If you read all the lectures during the semester, you will see many explanations. There are topics concerning vibrations, for example. There are topics concerning the computer logics and the dynamical interaction between the devices and the computers. Why is that so? Why do we need it? What do we need it for? It is due to the, say, dynamical abilities of a computer to collect the information. That's not exactly electromechanical interaction, but it's kind of a reading information. Actually, it is reading information from the sensors during machine operation. Okay, so when we talk about dynamics, and we are today living in today's industry, which builds machines, electromechanical devices, all built up with computer sensing management systems. Well, it's all working as one, as you already know. We need to study their dynamical interaction, mechanical, electromechanical, and computer interaction management. Okay, so let us start with the vectors, and when we practice the vectors, we will continue with the others. So first tasks are very easy to be understood, which help you to get into the kinematical and dynamical science quicker. Okay, let me say another few words about it. So the study of motion is called kinematics, which involves the use of geometry and the concept of time, whereas the study of the forces associated with the motion, that's what I just mentioned, but said with other words. It's called kinetics, or the dynamics I already mentioned, and involves some abstract reasoning and the proposal of basic laws of interaction, physical, mechanical. Okay. We will use some equations of statics in some cases where there is no motion at some instances of time. But actually, statics, to be honest, is another way of explaining the kinematics, which what I already mentioned we use for the dynamics explanations. Okay, let me say something else. Okay, let us start with the first one, which is position determination. Okay, let us write the task, write down everything, and proceed with the solution. So, a surveying instrument. It's a type. At point C, I will bold the C so you can recognize it as a point in space. I can measure. Okay, it keeps bolding. Distance and angle. All right, relative to the fixed X, Y, and Z axis. Okay, at C, I will stretch the text here so we can use the whole of the page. By the way, I will bold the X, the Y, and the Z axis. So at point C, point A, point A is at an elevation of 9.2 degrees. And the thing is the following. When we continue above the horizontal Y plane, okay, bold XY plane, all right, okay, okay,
where you want your screen recording saved. I usually
okay,
choose the Photos app. If you
okay.
want to record your
Now,
voice while screen
let
recording
us
on your
continue
iPhone,
XY plane.
you want to make sure that
The
microphone is
body
turned on.
of the
Note this will
instrument
also record in-app sounds.
has
Only want to record the
to
sounds of an
be
you want to make sure
rotated
the phone is
about
turned off.
the
So just
vertical
tap the microphone
axis
on to turn it on or off.
to 41 degrees from the X direction. Okay, so that's the X direction. We will have to build up the graph related coordinate system according to the text explained here. So, X direction in order to be a line with point A. Okay? Point A. Just another one more here. Alright. Just a second, I need to. Alright, it's better now. Point A. The distance from C to A is 5,005 meters long. So I will bold here the A and the C as well. And I'm ready. Now, corresponding values. For corresponding values for point B are the following: 1.3 degrees. Same way, elevated, and after that around the x. I will explain everything. So it will be 73.4 degrees. And distance is 7,037 meters. So the aim of the task is the following: determine. First thing we have to do is we determine the locations of points A and B in Cartesian. I will explain. Cartesian coordinates relative to the axis at C. Okay? Alright. When we're ready with the first task, we will have to continue with the next, which is B. And it is the following: the distance from A to B. As the second one, I will bold them as well. The last one to be preceded is the distance from A to B projected on to the horizontal plane. Now, that's the horizon, alright. Horizontal, I mean, not horizon, alright. I will leave the dot here and write solution. Text here and start. Now, what I need you to tell me, because I don't see you, is please let me know when you're ready, or if you have missed something, just let me know, or you don't read something, or I may have missed something. Please just let me know. Okay, so let us have a read on the So we've got automated system, surveillance system, which let's say record some is shooting around. Alright. The thing is the following: it is at a certain point related to some coordinate system which we have to assign in our space. So let us start with assigning the coordinate system. First, what I'm going to do, actually I will scroll down a little like that, so you will be able to read the assignment as well. And after that, I will draw that coordinate system, and after that, okay, let me denote that coordinate system. If that's the Z, that's the Y, that's the X distance. So our surveying instrument at point C, we will assign it to the center of the coordinate system. It will be denoted with a letter C, like that. Okay. Actually, I will use different colors to assign the letters. Actually, I will change it now with red color. We'll change all of them, by the way, so it will be easier for you to read it. So once again, the Z, the X, and the Y. Well, we are ready to start with our solution. Many times now we will use our drawing to proceed, ease ourselves with the solution. Okay. Now, I will. So we're ready with the first sentence in our text assignment. It is to assign C to some coordinate system, which should be Cartesian type. Cartesian type means rectangular type coordinate system. Okay. All right. So we will continue with the next sentence, the solution, and say the following. So related to that very same coordinate system, fixed x, y, and z axis. Axes I read the text at point C. Point A is at an elevation, it's higher, but at an angle of 9.2 degrees. What I will do now is the following. I will write point A here in space, which I don't know the position exactly. We'll mark it here in the space and say the following. So it is at higher position related to C, but at an angle of 9.2 degrees. There is no distance at the moment set. There will be, but we will have to determine it exactly. And so it is above the horizontal XY plane. Let me mark with green color. Our XY plane is this one. So that's exactly what we could call the horizontal. Okay.
Business owners and entrepreneurs leverage the
Okay.
power of video.
So our Z distance will be the vertical direction where we will elevate our point. Now,
So if you're looking to use
such
video
a case,
or strategy this
I
year,
will
then be sure to
delete
subscribe and click the bell.
the horizontal plane marking hatch here
What I'm about to share
and
with you might be
continue.
one of the most
So
underutilized
related to
tools
the
that the iPhone has. So you
XY
do not need any
plane.
additional plugins or apps or
Okay,
anything like that.
that's the second sentence.
So
The
what you
third one is the following. The body of the instrument has to be rotated about the vertical axis, but we already mentioned assigned z-axis to be our vertical one.
settings of your
Through,
phone.
so it is rotated about the vertical axis through 41 degrees.
And what you're
Well,
going to do
what
is
I
to
suggest
scroll down
is
until
the
you see
following.
screen recording to click
Uh,
this icon and it will go up
we
to
use
that section.
some additional lines here to explain that distance. What we can do for that is we can use the blue color to draw these distances. Let us imagine for a while that we can draw on the same horizontal plane, X, Y plane, where I used the green hatch line, which is going straightly to point A, but without an elevation. It's only on the ground, let's say. After, I will draw another one vertical line with, which is going upward to point A. And things now will get more clear for you and easier to understand. So, do you understand things up to now? Have you got any questions?
No question. No.
All right. Okay, let us continue. If that's the case, I can draw the following. I can draw the line here and say the following. We'll use the red color for the dimension. Here, that's the angle, and that's another one angle. Why do I draw these angles? It is because, once again, I read the text, and even I can underline the values here, 2.9 degrees and 41 degrees. But I will repeat on purpose. Elevation at 2.9 degrees. Well, that's exactly the elevation.
Right now in order to record my screen. And
Okay.
just a little hack just to show you how I create this graphic here.
Okay.
What I've done is I take a
Why
transparent
is
piece
that so?
of an
It
icon,
is because
just
point
over
C
the screen.
is exactly on the central coordinate system. It is on the so-called ground, the horizontal plane, which is XY plane, and point A is
Center
at higher position, which
button,
is not
and then it will with a
explained by dimensions but by angles. When we use spherical coordinate system like spacecrafts oriented. Alright, okay. I will explain about that later. Let us continue. Actually, I just wanted to say that planet Earth is kind of a spherical coordinate system. It's not Cartesian type, but that's something else we can discuss later. In details further. Now, I will write 9.2. 9.2 degrees. And the second is rotated by about the vertical axis through 41 degrees. So if that's the vertical axis, I can start from here. Like you can imagine I was here and start like that, rotating. If we look at the top, it will be a kind of a counterclockwise rotation. Alright? So there's no problem about it. So when we're ready, we can say, we can arrive the following dimension, 41 degrees around the vertical axis. Okay, that means we're ready up to the assignment here, and we can continue reading it just to accomplish all the 3 assignments in our task. Alright. Okay. The text X direction in order to be aligned with A, exactly in that sentence, last part of that sentence, is exactly the meaning that we start with the very rotation starting from the X, as I drew the line um, which aligns exactly with the x-axis. And after that, we start rotating at 41 degrees. You know, the right angle is 90 degrees. So that's approximately very close to the 45 degrees. It's approximately very close to the half of the right angle. Okay, so the x direction I read here in order to be aligned with a exactly is the meaning of the direction of that. Okay, all right. Okay, I will delete it just to maintain the graph in a clear position. All right. Okay, now to be clear. All right. So the distance from C to A, well, actually, there is a distance given to us, which is 5,005 meters long. And we can do the following. We can write lowercase r, which will be concerning this hypotenuse. Okay, that's distance r. All right. All right. And that's the distance r. Then we have to we will have to write the following. I will write it in the lower row here. But with the black color. Equals 5,000. So if lowercase I will rewrite it once again because I don't like it like that. So it will be 5,000.
Ne oldu? Buradan bakayım mı hakikaten?
Not that, but well readable enough, I think. Now, the following, the thing is that we need to use read actually the rest of the text, and it says the following: the distance from C to A is 5,005 meters. We already did that denotion with lowercase r. Corresponding values for point B are 1.3, 73.4, and 7,037 meters respectively. What is the meaning? It is written in short, which means the following: 1.3 degrees at elevation, 73 point something degrees at rotation, but the same way, starting from axis X, as we said. Now, actually, I will use the point as a decimal separator. All right, so decimal separator like that is okay. Well, what I can do is when we finish, actually, I can do the following: write point B in space. Maybe not exactly the position it should look like, but at least we have to start from somewhere. By the way, as a solution, I will write here point A, not here, but here. A. Now we're ready, okay? So let me continue drawing the point B. That is a another one distance. Maybe I will change it like that. Point A, I will move to the right. Maybe it would be better if it is positioned in such a way that they are recognizable. So I will change the position of point B like that, and continue with the distance here. Alright, okay, and finish with the distance in the following way. So I can move the coordinate system like that. By the way, I can draw the right angle here for the elevation. So it will be easier for you to understand the position. Alright. So when we add the vectors in such a way, we'll have to be sure about their relative, to find out their relative distances between these points. We will have to be sure about the exact position related to the center of the coordinate system, right? Okay. Now, let us continue. Well, I will have to I will have to do the following. Additional denotation we have to apply. Well, the distance I can denote with R, but I don't want to do it now. We'll explain why. It is because I want us to find the solution, and after that, for the first assignment, and after that, we will continue the very same way for the next, in order you practice best. If in our case we know the position of A, we will find the position, the solution for A, and after that we will continue with the same denotation. Alright, if lowercase r is 5,005 meters long distance from the center of the coordinate system, point C, well, we want to find the following: locations of point A and B in the coordinate system, Cartesian coordinate system, all related to C. Let us start with point A. Well, I can denote the height of point A with Z. The horizontal distance, uppercase R, we can denote with uppercase R, which is exactly the distance from the point center of coordinate system C to the position of point A, but projected on the horizontal plane. Alright, so what we can do for the solution in our case is the following. By the way, let me continue with the denotation. Actually, we have to finish the elevation angle. We will denote with using letter of phi, like that. The rotation around the vertical axis we can denote with uppercase phi, like that. theta, sorry, not phi, theta. Okay? Alright. Okay then. Well, when we know about the both of the angles and we have denoted them all, then we can start with our solution. And let us, for example, let us start with the vertical one. By the way, I will switch the color to black one and continue with writing it. Alright, so Z equals the distance r, lowercase r, very same r, which equals to 5,005 meters long. By the way, I will write theta equals 41 degrees once again. So these are the values we use in our case. Phi equals 9.2 degrees angle. Alright, so to find the solution of that task, we have to use the trigonometrical functions for solving it. In our case, to find the z distance, we will have to use the sine function, trigonometrical function, sine function of the angle of elevation, because z is the height, so sine of phi. Okay, so let us substitute the values and obtain the result. R equals 5,005. Multiplied by the sine function of that angle of phi, which is 9.2. Okay, now let us proceed with the solution. Let us perform the calculation. So I will wait for you just a few minutes, just even less than a minute you need to perform the calculation. So let us calculate the trigonometrical function first, and after that we will multiply the result with the to the distance. So sine of 9.2 degrees is 0.1598. Do you obtain the same result? Okay. After that, we multiplied by the 5,005, and the result we obtain is 800.2 meters. Okay. Alright, let us continue. The very same way, uppercase R equals this, so that's the other side, the other one distance in that triangle, right angle, okay? Okay, so R equals, once again, lowercase r multiplied by the cosine function of the same angle phi, Why we use the same angle phi? It is because we are still in the same triangle. So it is once again 5005 but the cosine function of 9.2. Okay, now let us proceed with the calculation of cosine function, 9.2 degrees. So the cosine function of 9.2 degrees is 0.987. Okay? Yeah.
4,940.
When we multiply by, yes, exactly. Exactly. Now, may I ask you something? What is the value after it is 40 point? What is the value?
0.61.
Exactly. All right. Let me write it as a result, as you told me. 4,940.
Yeah.
You told me.
Yes, 40. Point
Point
60.
61.
Yes.
All right. Okay. In such a case, when we are ready with this one, we can apply this very same method for obtaining the rest of the results we need to find in our solution. Now, what I want to say is that we need something in addition. We still know that this line, very same line denoted with uppercase R, is laying exactly on the horizontal surface. I drew the green hatch you saw before. Let us use the green color in this case and denote the distance or the projections of that uppercase R onto both of the axis X and Y. So I got, for example, Rx and Ry. Okay? And what we get as a result is the following. So we can continue the same way of the solution, but so Rx means the same uppercase R, but projected on X axis. If we are on X axis and take a look, we will see that long line uppercase R, but at an angle, in our case, at 41 degrees angle. Well, we want to find them because we want to ease our solution for the next two steps, okay? So, when we talk about the uppercase R, then we have to substitute the uppercase R, once again multiplied by the cosine function. But I have to say cosine function, but this time it is about the theta angle, because now we are laying on the horizontal. that's not the vertical plane anymore. It is a horizontal one, part of it. So I will write theta. Let me say something. What is the way for me to choose the sine or the cosine function? Depends which is first, right? Okay, when, for example, let us explain the first solution. When there is the z distance and the lowercase, the inclined line lowercase r, we write the following. I will write it with the green color here aside, and after that I will clean it because I don't want to mess up here with the solution. Now, z equals r sine of theta. That's what we wrote so far. Of phi, I'm sorry. It comes out from the following. Z divided by the r, mathematically you know that transformation, equals to sine of phi, okay? What is the meaning of that? It is the following. Z related to the r. Actually, that is the sine function of the very same angle, 9.2 degrees, because it is the opposite cathetus to the hypotenuse of the triangle. That's why I choose the sine function. Why do I choose the cosine function in the second row? It is because it is the close, another one, cathetus to related, if we apply the same rule as the first one. Uppercase r divided by the lowercase r gives me the cosine of phi. And exactly that's what it is. Okay, so I will clean this one. Have you got questions so far? Anything to ask? Anything to say?
Yeah, clear.
Okay. Let us continue. Right. I will have to clean it up. Just leave it better readable. The yellow one as well. Now, actually, what I am doing now is absolutely the same thing, but now I'm looking at not the vertical but the horizontal one, and here our angle is theta. That is all. Alright, let us continue with equal sign and the solution. Now, uppercase r equals, now let me remind you, distance from C to A is 5005, okay, but that's the inclined 5005, okay, that's our 5005.
Yes.
But the horizontal uppercase r, you told me the result. By the way, I missed here the meters. Alright, I'm ready now. So it is 4,900 something. Well, I will have to do it. I will have to use it, continue my calculations, 4,940.61. Once again, the very same reason I'm using to apply the cosine function of theta, which is x related to the hypotenuse. Alright, so it is cosine of 41 degrees. Okay, can you tell me please the result? By the way, I will prepare the solution for the next y equals r, and the opposite trigonometrical function is sine of theta, which is once again the same distance we found. There is a lot to be explained, used via the vectors. Alright, sine 41. So, what is the result? Could you please tell me?
3748.72.
48.
No, 28.
Sorry, 28.
Yes.
28.73.
725.
I
Okay.
think 1 point after the decimal is enough,
Oh, okay.
precise for us. Okay?
Okay,
But we
perfect.
have to take into account the second digit after the decimal point because it influences the first one. Yeah. Doesn't it? Yeah? Alright. Okay, let us continue with the next. So this time it is the sine function.
$3,241.
3,000. Yes, just a moment. I have to write it here. 3,000, you told me? 200?
241.
Alright.
0.33.
Okay, it is only the 3 enough
3,
for
okay.
me in our case. Now, it would be better for us to write the following sentence. So, point A, located at coordinates. It has the coordinates, the following coordinates. Now, we will use that denotation for the following. So, I will use the brackets. We will use it for the further solutions in our task. Point A. Now, let us say something as a basic. When we want to explain a point in space, but in a rectangular coordinate system, Cartesian coordinate system, we need basically, usually, we need 3 distances from the center of the coordinate system. That's how we find its position. Okay, so distance x, y, and z. Are we able to do it? Yes, we are, because we've got the x, the y, and the z. I can use the arc here. Denote it, make it the same like the rest. So reminding here that the z actually is the vertical distance, the x is the x direction distance, and y is the y direction distance. Have we got all 3 of the distances we need to explain the point in space? Yes, we have. So let us write it. Rx is, and I'm writing 3728.73, comma. Now, I have to say something in addition, but I will do it when I finish this one. X, Y, Z. Never forget that. It is always with the X after the Y, and the last one, the third one, is the Z. So the next one is 3241. That is the Y coordinate. I will explain it in a while. Point 3. And after that, the third dimension is 800.2. Now, write something. Point coordinates. We denote with x, y, and z distances.
Professor, thank you.
Alright, now let us read the distance from A to B. But what we have to do is we have to find the B position as we did for A, and after that find their distance between them, I mean from A to B. If we already did the A, we have to do it for the B. Okay, let us continue. So, we will proceed the very same way, but this time we will denote with R1 because we already used R. So, R1. This time I will remind it is 7,037 elevation angle and the rotation around the vertical axis. So I will prepare ourselves like we just did, and R1 for point B equals 7,000 and 037 037. Okay. What else? We have to proceed with the angle. I will add subscript letter 1 for all of them, just in case we distinguish them. That one was the first one without a subscript is for point A, but this one we need it for point B. 73, I remind myself, 0.4 degrees, alright? And phi, the elevation angle, I write last, it is, writing in last, okay, 1.3 degrees. Alright, so what we have to do is absolutely the same way. Let me say something else. Why did we proceed like that? Actually, because when we find the horizontal projection, we will be able to find the x projection and y projection. And I remind you once again, I need the x and y projections just to prepare the coordinates I will need for the further calculations. That is all. So it will be always like that in mechanical science. I mean dynamics. It will be always following some procedure or looking the path, finding like geometry classes, finding the solutions you are able to until you obtain the final result you are looking for. So let us proceed this time absolutely the very same way we did. So I will denote very same way we did. So I will denote here Z, even though I know that's the RZ. Alright? RZ, which equals, by the way, this time it is the angle, I mean the triangle you are looking at, which points point B, the uppermost position here, upper point. Alright? So it is R1, uppercase R1, Z1. Let me do it. Z1, R1. But that's for the horizontal, okay? This one, here. Okay. Well, I can do it. And actually, because the method is absolutely the same, so we write absolutely the same. R1 multiplied by the sine phi. Actually, I will add 1 as a subscript here because I missed it, and I just want to distinguish it from the previous one, phi1. Okay? And what I have to do now is just substitute the values, that's all. 3, 7, sine of 1.3 degrees. Is that correct?
159.6.
150. I'm sorry. 9.6. By the way, I forget to add the meters. But actually, I won't do it anymore because it is the meters after all in our case.
Okay.
And the obtained result at the end will be meters. All right. Let us continue with uppercase R. 1. So once again, we apply the same method. We're looking for it. And after that, we will split it to the x and y distances. So R1 is the cosine. R1 lowercase R1 cosine function of phi1. Okay. So once again, I substitute the same values.
7,035.
Are you sure about it? Let me check.
1.3 cos multiply. Yeah.
Alright. Alright. Okay. Rechecking everything. 7,000 you tell me, yeah?
Yes.
Yeah, okay. 37. Alright, 7. $1,035.
Yes.
Is there a value greater than 5 after the decimal point?
Just a moment. 0.1.
0.1. Alright. 0.1. Okay. Okay. Let us continue with the rest. Rx, uppercase Rx. 1 is the following. R1. By the way, I didn't. May I ask you, have you got classes after that?
No.
All right. Let us finish just a few minutes more. Cosine of theta. Theta. What is it? Yeah, theta. All right. So once again, 7,037 cosine. No, 70. I'm sorry, 73.4. Yeah. Okay. I think everything is okay. Yes. And the last one. RY. 1. But we will write a little sentence for point B. The coordinates are, and we will use the short denotation for that in a while. Let me finish the last one. May I ask you to tell me the result for both of them?
The first one, 2010.4.
And the last one, oh,
Last one.
I missed it. Just to write sine 73.4.
6,743.7.
0.7.
Yes.
Correct. Now, let us write the sentence. And after that, use the short denotation for the addition. It will be easy for us to continue with the rest next time and proceed with the next tasks. Now, point B is located at should be slowly, and here I will write. So, which one is the x? It is 2. 1007.4, you told me. Comma. Y. It is 6,743.7. 7. Comma. And the Z is 159.6. Now, the short way of denoting without any text is the following. Just we write it the following way. B. That's all. Enough for us to understand what is the information, okay? Short. Not shortly, but written in short. Because shortly, the meaning in English shortly means quickly, almost. Yeah. So did you succeed to write everything up to here so far?
Just last word.
It's okay. Take your time. Okay. What about the others? Actually, I'm not looking at you at the moment. I don't see you. I'm not watching the list in Microsoft Teams. Just looking at what we are writing. That's why I'm asking, is everyone else ready? Have you got any questions, anything to say?
No, I am ready to.
Okay, if you're ready, I suggest we finish like that. Now, next Monday we continue. Let me repeat something. It's important for me. Once again, next to the general tab, that's the posts in Microsoft Teams. Next, on the right side, next to the posts, it is the files, where all the lecture notes are uploaded in Teams. You can read them all. I have to ask you to read for next Monday first 3 lectures. They are numbered with first, second, third, so on. So next Monday we meet each other at 1:45 in the afternoon, and I will ask you if you have any questions on the first 3 lectures. And we will have a talk, and after that we will continue. So we will take the time. We will take the time for it. Okay? First lecture is very easy, just introduction of the dynamics in mechatronic systems, the problems solved there. you may meet in your future practice. And after that, the next lectures take you into the kinematics, the dynamics, and other topics interesting for you.
It
Okay.
will be much harder, I think.
No. We will explain everything.
Okay.
Everything will be explained when we finish the semester. There will be preparation for the exam. Explain you everything, so you will be able to prepare yourself without any worries. Well, yeah, you have to read the papers, ask anything you need to know. That's it. But take your time. Read them. Just read them. That's all.
Thank you so much, sir.
You're welcome. See you next time.
Thank you. See you.
See you. Bye.
See you. Bye bye.